Good morning students, God bless you. Welcome to 12th standard business maths class. The last class we have discussed forward and backward Newton's interpolation formula. In this class we are going to see about Lagrange's interpolation formula. The Lagrange's interpolation formula is also already discussed. Okay. The exercise 5.2 10th question, use Lagrange's formula and estimate from the following data the number of workers getting income not exceeding rupees 26 per month. Okay, not exceeding rupees 26 per month. Income not exceeding rupees 15, 25, 30, 35. Number of workers 36, 40, 45, 48. Okay, using the Lagrange's formula. Okay, the solution. From the table, the x0 is equal to 15, x1 equal to 25, x2 is equal to 30, x3 is equal to 35. Okay, this is from the table x0, x1, x2, x3. The same manner, y0 is equal to 36, y1 equal to 40, y2 is equal to 45, and y3 is equal to 48. Okay. This is from the table. Then x is equal to 26. This is also given. Okay, from the question, not exceeding rupees 26 per month. X is equal to 26. Then using the Lagrange's formula. Okay. Therefore, by Lagrange's interpolation formula is y is equal to f of x, which is equal to, we have x3, we have up to x3 and y3. So write the formula x minus x1, x minus x2, x minus x3 whole divided by, the x0 is missing, so x0, the beginning of value is x0, so x0 minus x1, x0 minus x2, x0 minus x3 into y0. Okay, plus then x minus x0, then x minus x2, the x1 is missed, so x minus x3, because x3 value is only obtained, no need to write x4 and x by x6. Okay, then the denominator is x1, x1 minus x0, x1 minus x2, x1 minus x3, then the y1 plus the same manner x minus x0, x minus x1, then missed x2, so x minus x3 whole divided by, so x2 minus x0 and x2 minus x1 and x2 minus x3 into y2. Okay, plus x minus x0, x minus x1, x minus x2, then x3 is missing. Okay, because x3 is the last value, so x3 minus x0, x3 minus x1, x3 minus x2 into y3. Up to y3 we want to write. That's all your formula. Okay, have you understood? Then substitute the value. So all values are already have. Okay, carefully substitute and making the simplification, we get the answer. Okay, is equal to y equal to, first x minus x1. So x value is 26 minus x1 value is 25. Then x minus x2, so 26 minus 30, then x minus x3, so 26 minus 35 whole divided by x0 value 15 minus 25, then 15 minus 30, then 15 minus 35 into y0. y0 value is 36. Okay, from the table plus. Okay, then x value is 26 minus x0 value is 15, then 26 minus 30, then 26 minus 35 divided by x1 value is now is 25. So 25 minus 15, 25 minus 30, then 25 minus 35, and y1 value is 40 plus 26 minus x0 is 15. Okay, then 26 minus 25, then 26 minus 35 x3 value whole divided by the x2 value. X2 value is 30, so 30 minus 15, 30 minus 25, 30 minus 35. Okay, y2 value is 45 plus then x minus x0. Okay, 26 minus 15, 26 minus 25, then 26 minus 30 whole divided by, so x3 value is 35. So 35 minus 15, 35 minus 25, then 35 minus 30, y3 value is 38. Okay, that's all. Okay, then making the simplification using the calculator, making the simplification. Okay, here using the bracket simple, bracket of 26 minus 25, then 26 minus 30, and 26 minus 35 into 36, the numerator values. So totally 1296. Y is equal to 1296 divided by the denominator value. 15 minus 25, then 15 minus 30, then 15 minus 35 equal to minus 3000. Okay, minus 3000. Okay, then the second line is 26 minus 15, then 26 minus 30, then 26 minus 35 into 40, okay, which is equal to 15,840. Okay, plus 15,840 divided by the denominator value is 500. Okay, plus next simplification value is 4,455 divided by the denominator value is 375. Okay, next, then the fourth value simplification is minus 1368 divided by 1000. Okay, which is equal to y is equal to 1296 divided by minus 3000 is minus 0.432. Okay, then plus division of these two values is 31.68. Okay, plus the division of these two values is 11.88. Okay, minus division of these two values 1.368. Okay, and y is equal to sum of these two values 31.68 plus 11.88 equal to 43.56 minus then the sum of negative values. Okay, 0.432 plus 1.368 equal to 1.8. For y is equal to 1.8, value subtract, we get 43.56 minus 1.8 equal to 41.76. Okay, the y values are represented by the number of workers. So the number of workers cannot be in decimal. So y is equal to, consider the decimal, this is more than 5. So adding 1 we get 42. Okay, that is 42. Therefore the number of workers is 42. That's all. Have you understood? Okay, next 11th question. Using interpolation, estimate the business done in 1985 from the following data. Okay, the year and business done in lakhs are given. The years are 1982, 1983, 1984, 1986. Okay, the business amounts are 150 lakhs, 235 lakhs, and 365 lakhs, 525 lakhs. Okay, so listen carefully. The years are not in equal interval. Okay, so 1982, 1983, so next value 1984, then 1986. The 1985 is missing. It's not in equal in the interval. So in this slide given the question, here want to apply the Lagrange's formula. Okay, the intervals are equal means using Newton's backward formula because 1985. But here the intervals are unequal, so here use Lagrange's formula. Have you understood why I am using the Lagrange's formula? Comparing other sum to this sum, the intervals only change. Okay, the intervals are unequal means using by Lagrange's interpolation formula. Have you understood? Okay, so from the table, x0 is equal to 1982, x1 is equal to 1983, x2 is equal to 1984, then x3 is equal to 1986, then y0 equal to 150, y1 equal to 235, y2 is equal to 365, y3 is equal to 525. Okay, then the value of x is equal to 1985. This is your question. Okay, write the formula by using the Lagrange's interpolation formula. So you have x3, y3. Okay, so y is equal to f of x is equal to x minus x1, x minus x2, x minus x3 whole divided by x0 minus x1, x0 minus x2, x0 minus x3. Okay, here y0 plus the same manner x minus x0, then x minus x2, x minus x3. The next step x1 is missing. Okay, this is already known. So x1 minus x0, x1 minus x2, x1 minus x3 into y0. So now y1 plus x minus x0, x minus x1, then x minus x3. Okay, the second value is x2 minus x0, x2 minus x1, x2 minus x3 into y2 plus then x minus x0, x minus x1, x minus x2 divided by x3 minus x0, x3 minus x1, then x3 minus x2 into y3. That's all. Okay, apply the formula. Okay, that's all your formula. Okay, carefully substitute all the values. Okay, y is equal to, the values are 1985 minus 1983, 1985 minus 1984, and 1985 minus 1986 whole divided by 1982. This is x0 value. So 1982 minus 1983. Okay, 1982 minus 1984, then 1982 minus 1986, then y0 value is 150. Okay, then plus then x1 values. Okay, so 1985 x minus x1. Okay, x minus x0, 1982. Okay, 1985 minus 1984, then 1985 minus 1986 whole divided by the x1 value is 1983 minus 1982, 1983 minus 1984, 1983 minus 1986, then y1 value is 235. Okay, plus 1985 minus 1982, 1985 minus 1983, and 1985 minus 1986. Okay, 84 is now missing. Okay, then the denominator 1984 minus 1982, 1984 minus 1983, 1984 minus 1986, then y2 value is 365. Okay, then plus 1985 minus 1982, then 1985 minus 1983, 1985 minus 1984 whole divided by the x3 values, 1986 minus 1982, 1986 minus 1983, 1986 minus 1984, then y3 value is 525. Okay, I understood. Okay, which is equal to the product of all the numerator is 300. Okay, divided by the denominator values are is 8. Using the calculator, making the simplification. Okay, the numerator simplification is 300, the denominator simplification is 8. Okay, then the next value is minus 705 divided by the denominator value is 3. Okay, then plus the next value is 3285 divided by 2 plus 528 divided by 4. The fourth value simplification is 528 divided by 4. Therefore, y is equal to, the division of this value is 37.5. Then, okay, minus of 705 divided by 3 equal to 235. Okay, plus 3285 divided by 2 is 547.5. Okay, then plus 528 divided by 4 is 131.25. Okay, which is equal to y is equal to, consider the positive value 37.5 plus 547.5 plus 131.25, we get 716.25, then minus 235. Okay, which is equal to, making the subtraction, we get 481.25. Okay, that's all your answer. Have understood? Therefore, finally, the business done in 481.25 lakhs. Okay, that's all your answer. Okay. Okay, dear students, today's homework, book page numbers 118 and 120, example 5.22, exercise 5.2, question number 12. Okay, consider the question number 12. The intervals are unequal, so here also use Lagrange's interpolation formula. Okay, do it well. Thank you. God bless you.